Hi, I've been looking around for a motor controller for the my Pico W. I think I've actually found one. Kitronics from over in Europe somewhere. They have this little board that has mo can control two motors, and the Pico W can plug right into the socket there, so no wiring or breadboards or soldering needed. Your motors just have screw terminals. You got two motors up here, so you got two motors, and they have a couple GPIO pins, three GPIO pins broken out, and 3 volts and ground as well. They have an upgraded board that breaks out more of the GPIO pins, but it's a few dollars more. Uh, I'm in America, so I bought it from Pi Maroni, and it was 10.50 or something, $10.50 plus shipping, and quite economical for what you're getting. Like I say, you got a $7 Pico with headers and $10.50 for the board for under 20 bucks. You got your motor controller and your microcontroller for doing a robot project. So I thought that was kind of cool. Anyhow, so this I'm powering mine. You power it right here with I got just 4 AA batteries, so 6 volts coming in, and um, that's what I'm powering with. But this can handle up to 10.8 volts. And um, it's fine for little motors. You're not going to power a big robot with this, but it's not meant for that. I got these little yellow TT motors, and it works fine for those. Um, One of the things a lot of times when you just get a motor driver board, you don't have a way to power your microcontroller, your Pico W. Well, this actually has a voltage regulator built in, so it takes this whatever your incoming voltage is and allows you and gives you a 3.3 volt output in to power your Pico W. So you don't need any kind of extra battery or anything to power the um, microcontroller like you would if you had some other setup or something. If you just bought a motor controller board, you probably wouldn't have that option. Anyhow, so that's kind of cool that we got that, and it just like I say, they just show a Pico in here, but Pico W works just fine too. So, like I said, I just got this little two-wheel robot that I'm using, and it's got the Pico W and four wires going, 2 wires going to each motor, and um, good to go with that wiring, and nice and simple. And then just got the AA battery pack that came with the little robot kit. I don't know. I'm sure you can buy something similar now, but I had this sitting around. It's even got a broken edge on it, so um, I think that's why it was sitting around, because it was broken. I didn't want to use it. I put it to good use after all. So anyhow, so let's get to the code on how you control this. So we'll go to our Thorny, and where am I at? Right there. Been playing around. Let me get myself out of the way. I don't need to be big anymore. All right. So I decided that I wanted to be able to use this outside away from Wi-Fi. So I set this up to be in the AP mode, the Pico to be in the AP mode where access point. So it actually creates the Wi-Fi, and you connect to it with another device by uh, using the uh, uh, numbers that come with it, 192.168.4.1 or something like that is what the comes out to. And looking at other videos online, it looks like the ESP32s create the same one and everything. I think you could probably set what Wi-Fi. I don't know whether you can or not, but that's what comes up on mine too. So anyhow, So what we're doing is setting up a access point with our Wi-Fi. So we need our socket and our network to do that. And this is our network. And normally, if we're just connecting to the regular Wi-Fi router, we're going to be in station mode, STA underscore IF. When we're in AP mode, we do .AP underscore IF. And that gets us creating, and then we, instead of supplying somebody else's SSID and password, this is what the um, we're going to be creating our own, and that's what the password is for this. So we can change that if we wanted to. So anyhow, so we're creating our connection, and we'll talk about, well, this creates our connection, and then once we get down to that, we can got our connection established, and it'll print out that our connection is successful and tell us uh, our IP address that we have. So anyhow, so that's the Wi-Fi part of it. We have more down at the bottom on that, but um, we'll talk about setting up our motors. So the motor controller on this board uses 2 pins per motor, and for forward, pin 1 will be high and pin 2 will be low. Now the high pin, and then if for reverse, it would be the opposite. So pin 1 would be 0 or ground, and pin 1 would be high, so that it would go and drive your motor in reverse. But whichever high pin is, we can do PWM on that to control the speed of our motor. So, and then we got 2 motors, so we're going to have 2 pins per motor, and 2 motors, that's 4 pins total. So, let's see, I guess we haven't got into this yet, but this is my controller let me make it bigger here. So this is our controller for the thing. This is, like I said, if you look at the IP, you're probably not gonna be able to see it, but it's 192.168.4.1. But anyhow, this is the web page that I created with just 9 buttons on it, and you can see we have forward and back, and then we have spin right and spin left, and then we have back right, back left, forward left, and forward right, and we'll get into that in a little bit. And then you got stop in the middle. The way I set this up, you shouldn't need stop, but sometimes you do, so it's good that it's in there. So that's the 4 buttons or 9 buttons that I have, and so I decided, rather than make it hard on myself, I just decided to make a list of what each of those buttons would end up being when you use it on a motor control. So I have this list of tuples here that for each one of them. So 0000, of course, that means stop. So that's going to be stop. So M underscore dir sub 0 is always going to stop it. And we'll skip this one for now, but like this is your forward. So you got pin 0 or pin 1 high, pin 2 low, pin 1 high, pin 2 low for the motors. And then we'll skip over here, and then this is the reverse, and this has got the opposite. Pin 1 is low and pin 2 is high. So we have that. And then we can get into this. So when you turn in right, let's say if you're going forward left, your left wheel is going to go a little bit slower than the right wheel, and that's going to make you go forward and left. So that's why I have 0.9 here instead of 1. And then when you're on the right side, this is forward right. It's the right one that goes a little bit slower. And then we got the same way for the backing up. It got to 0.9 on the backing up. But we also have, when you're spinning, normally you have a 1010 or 0101. Gene, I'm on the thing. So we have to spin, it's one motor's going one direction and one motor's going the other direction. And to spin the other way, you just reverse them, and then you're doing that. So you got that. So I basically have the 9 keys of my keyboard, of my keypad, that are going to collect to that. And then we have the next line is just, we define our motor pins. So these are the pins that are hard wired into the motor driver from the Pico W. And we're just using a little list comprehension to create a list of drive pins. And we're setting the frequency on each pin and setting the duty cycle initially to 0. So I'm creating a list so that we can address these by index instead of by name. You'll see that it saves a whole lot of things. If you had motor, left motor, right motor, forward and reverse, then you'd have 4 different things that you'd have to list for each one of them. Where now I can just loop through it and do each of these at a time. So anyhow, so that's just setting up all the pins into a M drive list so that we can access them. Anyhow, we did all that. We're going to skip over to Webpage. I'll talk about that in a second. So all the purple is an big F string that we use for setting up. It's just basically the HTML for a web page. Okay, so now, like I said, we set up our Wi-Fi up there, but when you connect, it doesn't matter whether this is going to be the same, whether you use an AP or station mode, you're going to try to connect to your web page. And this is the same thing that we're using. We're trying to get that out of it. And we're looking for this T event. So it was originally touch event I had, but I decided I wanted to be able to use a mouse as well. So you'll see up in the thing that we're using pointer events instead of touch events. But this is just a string that I gave it so that it's looking for this string when we get a request back. It's going to see if that string T event is in there. And then we're going to split out what's after that T event. And it's going to be the number between 0 and 9. So, or 0 and 8, I'm sorry, 0 and 8, 9 numbers. And so 0 for stop, and then each one of the other ones in that list up there that we have. So that's what it's going to do. And then we're going to get that number. And that's going to be our, what we call the control position. So we're splitting that out. And then, like I said, out of our list of M.drs up there, which is our list of tuples at the top, we're getting the one out that we need. So the tuple out that we need. So like I said, this is control position. So it's between 0 and 8. So it's going to pick whichever tuple. And now M now is actually a tuple that we can work with. So then we're going to do, so this enumerate is like a indexing through. So your enumerator is the E, and then the M drive. So you're going to go through the M drives, and you're going to start at 0 on the enumerate, and then this will be each of the M drives. So we have 4 drive pins. So we're going to go through that, and we're going to set the duty cycle to M now dot E, which is our index of the tuple that we have, and then we're going to multiply it by 65 because we're doing between 0 and 1 for our numbers up in our tuple, and of course you got 65, 535 for the duty cycle, so we're just multiplying by 65, 535 for each one of those pins. Of course, the ones that are 0 is going to be 0 here, and 0 times 65, 535 is still 0. So the zeros are going to stay the same, but the other ones are going to change. And we're going to just send another website back and then close the connection, or web page. Going to send it back just to update that. And we'll talk about this GC collect in a second. And I put this in a try except loop just so it would reset it after we hit the stop button in our felony. So, and or turn it off. So we're good. So anyhow, all right. So I am not going to be the one to try to teach you HTML because I am very much a beginner on it. So I started off with buttons. I said, well, I know we want buttons. And if you do a button, just a regular button in HTML, you get this little gray thing. So then I had to go into the CSS side of it and figure out how to make the buttons a certain size, certain background color, and make the rounded radius on the colors and the radius size. And then if you push on, if you select on a word and hold down on a word on a button, if you hold down long enough, it's going to come up and think that you want to copy and paste it. So I had to also, after searching the web, you put this user select equals none, and then it doesn't try to select it for copy and pasting when you do it that way. So that's good. And that's in the style. And I also, like I said, got the header up here for robot control. So we got that up there. And then I've made a table, and that's why the buttons line up in a 3x3 style. So anything that's has a T in it, table row, table detail is each column of the row. So each of those is going to be just extra code in here where you're creating your table. And then each side of in each table detail, I'm putting one of my buttons. And if you see, I got this .b up here, so that just tells you what class it is. So if you put class B in here, it's going to inherit whatever the same style as whatever this .b is up here. Now, normal button behavior is if you have it and you click a button, it's going to send a message off right away, that you send a message, that you clicked on it. And a lot of times, if you do the beginner Raspberry Pi thing, that's what they're going to do, and you'll see that it sends that. But I wanted it so that if on my tablet, if I held my button down, the robot would go. If I pulled my button, if I let my finger off the button, that it would send another message to stop it. So like I say, we're sending this. So this is the first button. So it's like I say, it's one is this forward left, I think. Yeah, forward left. But then that's on pointer down. So that's either a pointer is either the mouse can be doing it, or that your touch or your finger can be doing it, or a stylus if you have a pad with a stylus. And then they have mouse down and mouse up, and then they have touch start and touch end, which would be touch. And then I found that they have this new thing called on pointer, and that takes care of whether you're using a mouse or a pointer. I say new thing, it was new to me, so I don't know how long that's been around. But it accounts for both mice and touch screens. And it does work that way. So I've used it on both right so far. So then, like I said, when you're doing that, you're sending. We'll talk about that in a little bit, but this is what you got, and then I have this just puts in there forward, left, forward, forward, right, and this is all the things. And like I say, we got that for 9 buttons, and when the button's up, you can see they're all zeros when the button's up because you want it to stop. Even we have the button stop here in the middle. Well, if you push the button down, it's going to send a stop, and when you release it, it's going to send a stop. And um, we'll talk about that in a little bit. But like I say, it's 0 through 8 you're putting in there. And when you do the click, you don't have to, it's automatically sends a response to your web page back to your server, or, and so you would get that data coming back to the Pico if it was just a click. When you got this on pointer down and on pointer up, it does this function, whatever function is. So I had, like I say, I start out with mouse. So M down and M up is the function, 2 functions I use, and it passes this argument into the function. So we can get down. So not only do you have to use HTML, but I also had to learn, which I knew a little bit of JavaScript anyhow. And I I enjoy watching. I don't do much. I don't copy him too much, but if you ever have some extra time on your hands, go watch the Coding Train. That guy's crazy, and he can do some major things. He has a drawing program that's called P5JS, and it's a 2D drawing program. And I think it actually does 3D now, but it was originally a 2D drawing program. And it's amazing what he can do with a little bit of code. But it's in JavaScript, so I watch a little bit of his stuff, so I'm familiar with some of the ways it works. So like I said, we got our M down and M up here function. So when you put that inside of your HTML, you have a script tag and then a end script tag. So, and then you can put your functions in. And like I said, we're passing in whatever number is in there. So we're getting that number available. And this is just, we're creating an event, that a HTML request, and we're sending that back. And like I say, we're having a T event. Remember, that's what we were looking for a little bit down. And then we're just adding concatenating the 0 to 8 on top of that, whatever the it's getting passed to the function, it's just going down into that. So that's cool. And then we just send it. So we have one, when you push your button down, you're going to do this function with whatever numbers in it. And then when you come up, it's going to be all zeros, but I decided to do it the same way. And it's just going to pass the 0 in each time. And then you do want to, like I say, on our clicks, we want to prevent default. So we don't want to send back click events. So I found this on another video that to disable click events, if you don't want to use them, you want to use the pointers only, then you can put this code in here to get it to do that. And you might have also noticed I mentioned this in the last one. So this is an F string, and if you put a curly brace in an F string, you have to, then what it expects inside is a variable or something that you're updating, and it's going to add that to the F string. So JavaScript needs to use the curly brace same way Arduino does to define the code that's in a function. So this, so that you know, so they don't think that this is a variable in here, that the F string doesn't think it's a variable. You put two curly braces together anytime you're doing it, and then the F string just interprets that as, oh, he wants to use a curly brace there. He's not looking for a variable inside of it. So that's why you got doubled up ones on all these. Anyhow, that's it. And I can possibly show it running here. I don't know how this is going to work. So we'll put the camera down. And I don't know. I'll try to hold it, but that's forward. That's back. And then you saw that it didn't actually stop. So sometimes it doesn't send it back right away. So that's why I have that stop button in the middle when I actually hit it. And then I'm going to spin right, and that's one wheel going one way, one wheel going the other. And then I let off of it and it stopped that time. And then we're going to do it the other way, and it stopped. And now we got one wheel, I got forward left, so one wheel's going slower and one wheel's going faster. Now the other wheel's going slower and the other wheel's going faster. But as I said, see, I did it again, so. And we got to stop. So anyhow, you can see that I don't know why, but it's probably my poor programming skills. But every once in a while, it doesn't send the correct, or it's not getting back to this accept thing. And one of the things I did, I looked around and they said, well, sometimes you get MicroPython gets their doesn't do a good job of collecting all the variables that you're using, because we're sending back a big chunk of data each time, you know, that this comes back. It's probably, it can be up to 1,024 bytes, but I think it's probably, you know, probably 400 bytes maybe that comes back, maybe 300 or 400 bytes, because it's like 4 lines of print on the console down here. And we're not using anything but you know, very few parts of that. And they say, well, maybe that's not getting deleted or something because we don't need it. It's just a temporary variable. So we have that thing called GC, which is garbage collecting. And then you call GC collect, and it's supposed to take care of getting the garbage out. It doesn't work. I haven't noticed any difference by putting it in or not putting it in. So I don't know if that's the cause or if it's something I programmed wrong, anything that I can fix. If somebody watches this and can tell me why, like every 10th push or something, that you don't get a stop when you let go of it, you can let me know in the comments for sure. But it's been a fun project, but I don't know if it's, like I say, it's, I sure wouldn't want to be having a motorized car going around and with a push buttons and not being able to stop when you had it. This little robot, like I say, I take it out and pester my cats with it. And I run into one of my cats with it one time and he didn't like it much. So anyhow, that's my video for this time. Like I said, it's a cool little robot, and I really, really like that $10 motor controller that, like I said, it's no soldering at all, and you got a little screwdriver and you put in your 4 motor wires, and you're good to go. So anyhow, that's my video. It's been way too long anyhow. Thanks for watching. If you have any comments, please leave them.